So this unit is very heavy on the graphing, but no graphing today. We're going to look at direct variation, which is a review of Algebra 1. Inverse variation is new for us for Algebra 2. And then joint variation is kind of like when you combine the two of them together. Straight from Algebra 1, direct variation is a special type of linear function, so a special type of straight line that is in the form y equals a times x. There's no plus or minus number. There's no, the y-intercept would be at 0 if you were to graph this. A is technically the slope, but whenever we talk about it in the sense of direct variation, we call it the constant of variation. Constant of variation. Okay, so looking at a little example, it says y varies directly with x. So I can tell right there that it is a direct variation equation because it says varies directly. And y is 4 when x is 6. Let's write the equation that models this. So first thing I want to do in this situation is to find out what my constant of variation is. So we need to find a. And we can find a using this y and x combination that we're given. If I were to take this little baby equation and isolate a, what would I get? Without any numbers in it. Yeah, a is y over x. There you go. Y divided by x. So I can easily take these two numbers and find my a. A would be 4 over 6. And what is 4 over 6 reduced to? 2/3 equals 2/3. So once I have my a value, then I can do step 2, which is to write my equation with a in it. So the equation would say, instead of y equals ax, we'll just take our 2/3 and put it in there. Y equals 2/3 x. So there it is, a cute little direct variation equation. Again, the y-intercept would be at 0 if you were to graph this. Oh, hi.
I'm so sorry. I was just looking.
Oh, you were looking at what we're learning?
Yeah.
Oh, nice, yeah. We're doing inverse and joint variation.
I'm so sorry. I didn't know.
Oh, you were looking at the setup.
Yes.
Yeah. Well, more people should be like me. Just be lazy and sit here. Okay. Algebra 2. Does anyone remember this from Algebra 1? It's just it's also kind of 8th grade, 7th grade math. It's like the very first introduction you get to like straight lines. Yeah. All right, we're mixing it up. Inverse variation is the part that's brand new for Algebra 2. It's also the one that we're going to see a rational function. So our equation for this would be y equals a divided by x. So remember, rational functions, like I said earlier, it's a ratio. It's going to look like a fraction, specifically where you have a variable in the denominator. A is still known as the constant of variation. Again, it is a rational function, so the independent variable, aka x on this one, is in the denominator. If I were to take this equation and solve it for a, what would that equation say?
1
X times y, right, because you would times x, so a equals x times y. So if I ever need to find the constant of variation for an inverse variation, I would just multiply my x and my y. Let's try one. Wording is going to be important on this one. So it says the variable x varies inversely with w. X varies inversely with w. So do y'all see where it says literally varies inversely? I know that's where my equal sign is going to go. So I'm going to have an x in the front. Okay? And then I'm going to have my equal sign where it says varies inversely. And then I know varies inversely means I'm going to get a fraction. On top is going to be our constant of variation. On bottom is going to be the variable that we're given second. So x varies inversely with w would be written like this. X varies inversely with w. And we're told when w is 4, x is 11. Write the equation for x in terms of w, and then we're going to use it to predict the value of x when w is 22. So to write my equation, the first thing I'm going to need to do is find a. Find my constant of variation. Find a. And we can do that using the two given numbers that W is 4 when X is 11. So to find A, we know we just need to multiply the X times Y, which technically for us would be the X times W. So A would be our X times W. Which means I'm gonna multiply which two numbers? 4 times 11. So what's my A value? 44. Okay. Once we have our A, then we can write our equation, just plugging our A back in. Right, equation. Okay, so my equation would say X equals, and then where that A was, what number do we just find? 44. So 44 over W. So there's our inverse variation equation. And then they did ask us to do something with that. It says predict the value of X when W is 22. So that'll be our last thing we're going to do. Find X when W equals 22. So I'm going to take that 22. I'm going to plug it into the equation I just wrote. So X would be 0. So kind of a 3-step problem on this one. We got this. We got our equation. You okay? Question? Ah, bless you. Okay. Look at the next one. I'm going to highlight where it says varies inversely so I know how to write my equation. The variable Q varies inversely with R. Q, and then where it says varies inversely with, I know I'm going to have my equals and a fraction. If it varies inversely with R, R is going to be on the denominator, and your constant of variation will be in the numerator. Okay, it says R is 30 when Q is 8. Again, we'll write the equation and then we'll use it to predict another value. So I'm going to first start by finding A. Find A. A on this one would just be Q times R, because you'd multiply by R, multiply by R. So I'm going to take my two numbers, my Q and my R, and substitute those. 30 times 8. So what's my A value? 240. I wrote a 3. 30 times 8, 240. Very good. Once we have our A, then we can write the equation with the A plugged in. So we'll get, let's see, Q equals, where the A was, we know it's 240 now. And we have the R on bottom. And then we'll do the last part, which is to predict the value of Q when R is 9. 240 over 9. I don't know if that divides evenly or if it just reduces. I don't think it divides evenly. Both of these numbers are divisible by what number? 3. So we can at least reduce it. If we divide them both by 3. What's 240 divided by 3? 80. And then 9 divided by 3? 3. So I can definitely tell that wouldn't reduce more because this 80 is not divisible by 3 now. And then that would be our final answer for our prediction. Not too bad. These are nice. They're kind of like little one-step equations. All right, looking at the bottom section where we have a table. We're trying to figure out just from the table, would it show direct variation? Would it show inverse variation? Or none of the above? Because, I mean, there's still other types of functions. It could be just any other linear function that has a y-intercept. If it was showing direct variation, I'm going to write this on the side of my paper. For direct variation, if we did our A equals y divided by x right here, find our constant of variation, it would need to be constant all the way down the paper. So if we check y divided by x and we get the same number all the way down, we know it's direct variation. Opposite of that, inverse variation. If we check our A equals y times x or x times y all the way down your table, then that's how you know it would be inverse variation. And then if none of those are true, if you try and divide your x's and y's, you try and multiply them and none of them work, then it's some other type of function, and you would just say neither. All right, so looking first, I usually check the multiplying one first because it's easier for me to visualize. If I did 1 times 1/4, what do we get? 1/4. If I did 2 times 1/2, what's 2 times 1/2? 1. So already I know it's not the multiplying one, so it's not going to be inverse variation. So then next I'll check the y divided by x. So let's see, y divided by x. So for the first one, it would be 1/4 divided by 1, which is 1/4. And then 1/2 divided by 2, 4th. 1 divided by 4, pretty easy, that's already 1/4. 2 divided by 8, 1/4. Just finishing it up, make sure the others actually work. Are they all 1/4? Awesome. What type of variation is it then? Direct variation. Is direct variation, the constant of variation would be 1/4. If we were to write the equation, which it didn't tell us to, so I'm not going to worry about it. Okay, same thing for the second one. I usually first try to multiply because that's easier for me to visualize. 1 times 0 is 0. 2 times 1 is 2. So already I know it's not the multiplying one because I did not get the same number for the first 2 rows. And then I try the division one. 0 divided by 1 is 0. 1 divided by 2 is 1/2. We got different numbers. So already I know it's not direct variation because the y divided by x was not constant. So what does that tell me about this table? It's neither. Good. None of those work. It's some other type of function, but not one of these variation functions. And then lastly, again, I usually check my multiplying first. 1 times 160. 160. 2 times 80. 160. So, okay, we're heading in the right direction. 2 times 80 is 160. I'm just going to verify that it's all 160 all the way down. 32 times 5, is that 160? You want to check that one? Did you? 10, 15, 16, sure is. What type of variation is this one then? Inverse. Inverse is the one where the x and y are multiplied. Inverse. It's okay. Did you write these 2 parts down on it? Okay. All right. You can also have a combination of these 2 types of variation together. Or a combination of like 2 direct variations, or a direct variation and joint variation, or and that's called joint variation. It's kind of like joins the 2 of them together. Joint variation is direct variation with more than one other variable. So it's not just one x and y. It'll have some additional variable. So if we see this first one here that says x equals a, y, z, this would be x varies jointly with, varies jointly tells me there's going to be 2 variables, with y and z. X varies jointly with y and z. So if I look at my first one, it says the variable t varies jointly with the variables s and w. I'm going to highlight that to help me figure out how to write my equation. Okay, so I know I'm going to have, right here where it says varies jointly, that's where my equal sign is going to be. So in front of that equal sign, I'm going to have my t, and then I'm going to have my equal sign. I do need to remember to write a spot for a, which is my constant of variation. So I'm going to say equals a, and then s and v. So s and v. Nowhere in there did it say inverse variation, varies inversely, so I know I'm not going to have a fraction on this one. T varies jointly with, I have my equal sign, my place for my constant variation, s and v. Passive. And then it becomes just like the front. It says s is 18, v is 12, t is 36. Write the equation giving t in terms of s and v, and then we'll use it to make a prediction. So again, because we don't know what this constant variation is, we're going to start by doing that. We're going to find our constant variation. And I can do that using this first combination of numbers. S is 18, v is 12, t is 36. So substituting those all in. S is 18, V is 12. So we'll solve this little equation for A. Anyone do 18 times 12? Anyone know that off the top of their head? 116. So then I have A times 216. How would I solve that for A? Divide by 216 on both sides. So I get A equals 36 over 216, which actually does kind of reduce kind of nice. 1 over 6. Sure does. Okay. Now that I know A, I can put my constant variation back in its little equation.
T.
So we'll get T equals 1/6 SV. There's my equation. So that's kind of one of my answers. And then lastly, we're going to use that equation to make a prediction. It says find the value of V when S is 30 and T is 2. So that's the last thing we got to do is find V. Hold on, let me plug in my numbers first. Okay, so what numbers do I need to plug in? 30 and 2 for T. Right, so a 2 right here where T is. We have our 1/6. S is 30. And then V is what we're solving. I can actually simplify a little bit on the right. 1/6 times 30 would be a 5. So 2 equals 5V. And then we'll isolate to get what for V? 2/5. Very good. Divided by 5, we get 2/5. Make me want to. Live on. All right. Chemistry. Anyone excited? Don't lie. I know y'all love chemistry. Combined gas law. We heard of this in chemistry already? We've heard of it? It is a inverse variation equation. States that the volume of a gas varies directly with its temperature and inversely with its pressure. I'll show you how to write it. Don't worry. Yes, you'll have to kind of do both, but they're in the same equation. Find the constant variation for a gas if it occupies 14 liters of volume at a pressure of 4 atmospheres. Oh, fun. And a temperature of 300 degrees Kelvin. All right, just trying to write the equation. Everybody see where it says varies directly with its temperature and inversely with its pressure? Okay, so in front of that, what will be our first variable? Volume of a gas. What letter y'all want to use? What? V for volumes. It goes. Volume. Varies directly with. I need to instantly put my place where I'm going to have my constant variation. Varies directly, specifically with its temperature. So what would I write next? T. And inversely with its pressure. Inversely with. Over. Yeah. Inversely with means it needs to turn into a fraction. So inversely with its pressure. I'm just going to use P for pressure. I don't know if that's the right variable according to chemistry land, but I think it looks good. Okay. We're going to find the constant variation of a gas if it occupies 14 liters of volume at a pressure of 4 atmospheres and a temperature of 300 degrees Kelvin. That's basically telling me variables to plug in so that I can solve for A. Okay. Was I given a V? Yes. What was I given? 14 liters. Equals, we don't know A. Was I given a T, temperature? 300 degrees Kelvin. My inversely with, was I given a pressure? Yep. What was it? 4 atmospheres. So I'm going to need to solve this for A. What should I do first to solve it for A?
Multiply.
56. Very good. 56 equals A times 300, which is just 300A. And we get A equals, it does reduce. I don't know if it reduces by by 4. Okay, let's try 4. I'm gonna use my post-it note for it. 56 divided by 4. 300 divided by 4. 56 divided by 4 is 14 over 75. I think that reduces further because 14 is only divisible by 2 and 7, and neither of those go into 75. So A is 14/75. That's all this first part asks us to do. It just asks us to find the constant of variation. I kind of separated it on this one. So that is my constant of variation. And then we're going to use that now. It says if the same gas is compressed to 10 liters of space and its temperature is raised to 300 degrees Kelvin, what would be its pressure? What would be its pressure? So we're going to need to use our equation now to solve for which variable? P, right. Solve for P. Pardon? So I'm going to write my volume equation. Volume equals, my constant of variation is 14/75. My temperature inversely with pressure. So we're solving for P, which means we should be given which other two? Temperature and volume, right. What was the volume? 10. What was the temperature raised to? 310 over pressure. How do I get that P out of the denominator? Multiply by P, yep, times P. So we get 10P equals 14/75 times 310 now. That looks like it reduces. Y'all know you can reduce diagonally, right? Like I can look at these two and reduce these like a regular fraction. What are both of these divisible by? 5. They're both divisible by 5. What's 75 divided by 5? 15. What's 310 divided by 5? Bigger than that. 30. Are you just guessing? 310 divided by 5. 31. Okay, I guess I'll 310 divided by 5. Starts with a 6.
65. 62.
30.
61.
62.
We knew it.
You knew it. Great guess.
Oh, I could see right away.
Okay.
Oh.
So now I have 10P equals, and I can do top times top, bottom times bottom. Bottom times bottom is pretty easy. That's just a 15 on the bottom. Top times top would be 14 times 62. No, disconnected. QZX 5GQ. LOL. We will never. 14 times 62. Anyone get it? 868. Yep. Okay, we got one more thing to get that P by itself. Divide by 10, but since I have a fraction on this side, the same thing, multiplying by 10, you can also do times 1/10. Yeah, which might be easier with my fraction over here. Times 1/10. So P equals 868 over 15 times 10 is 150. Does that reduce? Yeah, both of them are even, so I know it definitely reduces by 2s. 434/75. I don't think that reduces. 8, 9, 10, 11. It's not divisible by 3. All right, how should we label it? Atmospheres. They told us. Yeah, atmospheres. ATM. Atmospheres. What is that as a decimal? Just out of curiosity. 434 over 75, 5.786 repeating atmospheres. I don't know what that means
So cool.
as a non-chemistry person. I don't know if that's a good or a bad thing. All right, one last question. Get ready. It looks wordy. The weights in pounds that can be safely supported by a horizontal beam varies jointly with the beam's width and the square of the beam's depth, and inversely with the length of the beam. That's the equation part.
Just put it multiplying.
Multiplying and dividing, because it's both direct and inverse. I'm going to pause there and try and write the equation. We got to be careful because, let me see. Here's jointly with. We have two W's. We have weight and width, so we don't want one of them to be a W. What should we do instead?
Make one of them L.
Which one?
P.
P for pounds. That might be easier. Or LB, whatever. P for pounds. LB for pounds. Width can be W. Depth can be D. Inversely with length can be L.
So it's gonna be P equal to
P is equal to pounds equals.
W times.
Before you write W, you have to write a spot for your constant variation. So we have to put A, and then, yep, the beam's width. Oh, hold on. It says, and the square of the beam's depth times D, the square of the beam's depth. What does that mean? D squared. Yeah, D squared. And inversely with over L. There it is. Is that a coat?
Oh,
Colt?
it doesn't be.
It looks like it. Yeah, it looks like. Okay. There's our blank equation. Now let's see. It says, if the maximum weight that can be safely supported by a wooden beam that is 36 inches long, 2 inches wide, and 4 inches deep is 500 pounds, write an equation describing the relationship between weight, width, depth, and length of this beam. To write the equation, we basically just need to find A. Once you find A, you have your equation. Find A. Okay. What's my pounds number? 500 pounds. Yep. What was my width number? 2. 2 inches wide, so width is 2. What is my depth number? 4, so I need to write 4 squared. Also, just you put 16. And then what is my length number? 36. Yeah, super easy. The most common mistake on these questions is just forgetting A. People will forget A and then they're like, well, what do I do? Like, they'll leave this out and then just get confused about what they're solving for. All right, getting this one cleaned up. I'm going to start by just multiplying by 36 to get rid of that fraction. 36 times 500 would be 18,000. 36 times 5, and then 2 more zeros. And then on this side, let me see, we'll have A times 2 times 16 squared. So 16 times 2 would be 32. So 32A. And then we'll divide by 32. I'm just going to use a calculator. 560. 562.5. Bless you. What do we still need to do? Write the equation. So basically we just need to take this, we're going to substitute it back in here to write our equation. W times the depth squared and inversely with length. There's our equation. They didn't even ask us to do anything with it. All right.